All right, video today is on translations. We're finally starting to talk about some geometry stuff in this class. So today we're talking about translation. That's a type of transformation, and we're going to get into that. So how are figures translated on a coordinate plane? When you hear the word translated, you think, oh, maybe like, translating a word from English to Spanish, right? If you would say hello, right? You'd say, oh, that's hola. So it means the same thing, but one's in English and one's in Spanish, right? Or in different languages. So we want to go and talk about that today. This is going to be with shapes, however. All right, so a transformation. Let's start with that. A transformation is an operation that maps an original geometric figure, it's called the pre-image, onto a new figure, which is then called the image. Transformation. So you're basically taking some kind of shape and you're moving it somewhere, and it's, something's happening to it, but it basically goes from a pre-image to an image. Okay, that's a transformation. Okay, there's three main types we're going to talk about in this next week here. This is the first three types. There's translations, which is today's lesson, rotations, which will be later this week, and reflections, also later this week. Those are the three main types. Here's kind of an idea of what those look like. I'm sure you already know some of these. A translation takes a pre-image and it just shifts it, right? Just moves it, and that would be to its image point. So pre-image, image, can shift it left, right, up, down, diagonal, all these different directions. A rotation takes a pre-image and it rotates around a point. You'll find out more about that later this week. And a reflection takes an image and a pre-image and it flips it over a line of symmetry onto its image. So pre-image, that's before it moves, image after it moves. All right, so now we're going to talk about translation. So I gave you guys like a little definition box here. And I want to give you first a definition, just kind of in your own words kind of thing. So a translation, that's sliding without turning or flipping. So look over here. We're not turning it. We're not flipping it. We're just sliding the actual figure. Okay. Characteristics, it keeps the same shape. It's the same exact size, and it faces the same way. Right. So those are the characteristics of a translation. Okay. Here's an example, right? If you start with the pre-image and then you shift it over here, it's moving this direction. That would be called a translation. You're just kind of moving it over. Here's a non-example. You're taking this one and this one actually got rotated. So this is not a translation. Let's figure out how you actually translate on a coordinate plane. So when you're asked to translate units x and y, you're going to see that they're going to be written in the following way. They're going to say, look, x and y, you'll see a little arrow because that helps you remember, hey, translate, shift it. And it says, hey, take the x and add or subtract some number, and take your y and add or subtract some number. And that's going to tell you how much you shift left or right, up and down. So the a over here will move the point left to right, because remember, x on the x-axis, if you were to draw it real quick, x-axis is this way. So if I have my numbers here and I add or subtract something, I'm actually moving from left to right. The other number, this b1 here, is going to move the numbers up and down because it's attached to the y. And remember, y is the vertical axis, so any numbers there are going to move it up or down. So the best way I can explain this to you is just kind of show you an example. All right. So here's an example. I'm going to start with a pre-image, okay, which, I don't know, I'm just going to make up some points here. So let's go with this point here. We'll call this point here A, and this coordinate is -2, +2. -2, +2. Okay. The next pre-image point will be B. Let's make that, I don't know, over here. B. That one is 1, 2, 3, 2. And then the last point we'll just say is over here. C. And C here is -1, -1. Okay, and if I were to connect those points, I create a triangle. Okay. So if this is my image here, and I'll go over the details later, but if I were to actually translate this, and I say, look, you know what? I'm going to take this A, and I want to move it, I don't know, 2 to the right and 2 down. 2 and 2. That would be A prime. Okay, that's, you use that little prime symbol right there. And then you say, okay, that A prime new point is 0, 0. Well, if I move this 2 to the right and 2 down, I have to do the same with all the other points. So 2 to the right and 2 down, that would be C prime. And let's see, if I move it here, it's going to be 1, 1, 2, 3, -3. B, 2 to the right and 2 down, that's right over here. That, again, I call it B prime. And I'm going to say that that point is 1, 2, 3, 4, 5, right? Because I added 2 to that, and I went down 2, so 0. If I were to connect these points, you can see that I've created the same exact shape, it's the same size, and it's facing the same way. I just kind of translated, I shifted it down. Okay, so there's an example of it. Again, the pre-image, the red one, A, B, C. The image, that's after you make the move, is called A prime, B prime, C prime. Okay, notice that both shapes are congruent. There's that word again, right? Both shapes are the same size and same shape. Okay, we're going to try one more example here. Example number 2. Triangle XYZ has vertices x of 1, 2, y of 0, 4, z of negative 1, 4. As a reminder, vertice just means the corners of the actual triangle. Okay, so find the vertices of x prime, y prime, and z prime after a translation of 2 units left and 1 unit down. All right, so first of all, let me talk about the notation. How do you show that? You basically say, hey, x and y, whatever it is, draw a little line here, a little arrow says translate it by how I'm going to move something 2 to the left. Remember, if I'm looking at a graph, if I'm trying to go to the left, I'm actually going into the negative area, right? I'm subtracting. So I'm going to go 2 units left by subtracting 2. Then if I want to move down, remember these are up and down here, I take the y value. To move down is going negative, so I go minus 1. Okay, that's the translations, that notation that you should be familiar with. All right, so here we go. I'm going to start off with a table. I think this is probably the easiest way. I start off with my x, y, and z. X, y, and z, again, that was found in the actual problem. I just wrote it again. And then one at a time, I go ahead and follow directions. It says whatever the x is, subtract 2, and the y, subtract 1. Okay, so 1 minus 2, and 2 minus 1 will give me my new point. That one here, we'll call it as x prime. Then over here, 0, 4, 0, I subtract 2, 4, subtract 1, I get negative 2, 3. That would be y prime. Z, I subtract negative 2, and then the 4, I subtract a 1. Okay, I'm doing the same thing to all the x and y's, right? Whatever the rules tell me. That'll give me my z prime. Okay, and lastly, I just go ahead and graph both of them. I'm going to graph the original one. I'll graph that one in, let's say, blue. Okay, this is the blue one. 1, 2. Okay, that's x. 1, 2. 0, 4. 1, 2, 3, 4. That's y, right? 0, 4. And then negative 1, 4. That's z. Negative 1, 4. So it creates this type of triangle. Okay, remember, I'm going to be moving it 2 to the left and 1 down. I'll change colors for you. That's going to be x prime. So x prime is negative 1, positive 1. Did I graph something wrong here? 1, 2. No, that's right. Negative 1, positive 1. That's right here. X prime. Negative 1, positive 1. Y. Negative 2, positive 3. 1, 2, 3. That's y prime. Negative 2, positive 3. And then z, 1, 2, 3, 1, 2, 3. That's z prime, negative 3, 3. If I connect this, you're going to notice that I have the same exact shape, same size, it just got moved and it's facing the same way. All right, that's it for the notes. I do have an extra example video. If you're not getting this, please watch that one as well.